Okay, so it's my mistake, their fault. They didn't remind me that here, one of their classmates was gone. But one of the aspects that could happen is we could have to draw a tetros, okay, or even a triose in this example. And the number of carbons in an aldehyde sugar, that helps you with the shape. How or why? Yeah, if it's 3 carbons, it's a triangle. If it's 4 carbons, it's a box. If it's 5 carbons, it's a pentagon. And if it's 6 carbons, it's a hexagon. That's only the case for aldose sugars, okay? So for alpha D threose, then, here is our Fisher projection formula. That's step 1. Here's step 2, very similar to hexoses and pentoses. Here's that first carbon here, okay? Then our second one's on the left, so it's oriented up. The third one's on the right, so it's oriented down. Then here's the fourth one way out here on the end. That's step 2. Step 3, then, we called this what the, I think you had said what, flip and switch? Is that what we called it then? Okay, so notice that CH2OH was way out on the end. Well, that has switched, okay, and flipped with this OH molecule. So that's now out on the end. And then CH2OH is up on top and hydrogen is on the bottom. Then this is a reducing sugar. That's one of your vocab terms. That's what's happening when that double bond breaks. And then that gives us our OH on the bottom, that alpha D threose. That is the process of taking a tetros and closing that ring structure. Okay, same thing would happen if you were doing a triose. Okay, this is glycerolaldehyde in the same process. Okay, you got CH2OH way out on the end on carbon 3. Carbon 2 is on the right, so it's down, and here's carbon 1. Then in step 3, we see the old flip and switch. CH2OH is over here, and then hydrogen's on the bottom, and OH is out on the end. And then you would say the same thing. This hydrogen then goes down here and breaks that double bond, and now it's attached to that OH group. Okay. We went through and explained that a lot faster than how we went through here. That is aldose sugars. Okay? Let's go ahead and take a look at this tetros. That is a ketose sugar then. Okay. So I'll go ahead and erase this. So how do ketose sugars start? Flip it on its side, okay? Because notice you have both of these here, okay? So that is this carbon here, okay? Then if we back up 1, okay, here's another carbon, okay? All right, and then this is where it gets to be a little tricky, okay? Actually, I think I had maybe misexplained that. Just because you've got a double bonded oxygen on the first carbon on ketose sugars, it's actually on the second one. I was thinking this was supposed to be a triangle, but that is not correct. It would still be that of a box, like cyclobutane. Even though there's 5 carbons. Because if this one's number 5 down here, we back up to number 4, which is down, and we back up to number 3, which would be up, okay? Then we back up to number 2, which is right there, and then down to number 1. Number 1 is right here, okay? So carbon 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, 5. It's a 4-sided figure, even though there's 5 carbons to start out with here. Okay. So then what happens in our next step? Very similar to what we would have seen here. Okay. I don't know how well. Yep, that shows up on there. Okay. Okay. And then we got that one up. So what's going to be down here? Just like in aldo sugars. Okay. And then up top, H. Okay. Then what about here? Has anything changed though? You got to do the flip and switch. That's right. Okay. Which means hydrogen's now down here. This is now up top. And then, so there is our flip and our switch. So now we want to close this ring. This will go down here and break that double bond. Okay? And then we'll just close this ring. Now, when you're looking at this orientation, it's always about the OHs, whether it's in aldo sugars or keto sugars. So since that's in alpha position, this is down, because if we wanted this one instead, well then we got to switch these two. And then that CH2OH would be on the bottom. Okay. Since we started at 10:30, that's cut 15 minutes short than what your normal class period would be. So, first row. Okay. And the process is, it's not that it's identical, but it follows a very similar path. Second row, and then third row. Okay. So, we can make quick sense of that by saying, okay, what is a sugar that you are, or monosaccharide that you are familiar with? Okay, so if that's the case, okay, so again, very quickly, if this is the case, we can just flip it on its side and close the ring right away. Well, actually, we should probably go through that process of this. Okay. Oops, that doesn't belong on there. So that was step 1. This one is step 2. Okay, and then of course in step 3, it's that flip and switch again. So you've been doing this all along, but just never applied to a smaller monosaccharide. Here's our flip and switch then. And then OH is way out on the end. Then we're familiar with that like we've been doing in every step. That goes down there and breaks that double bond.
So you have another one up top, or another.
What's
Anything on the top left?
the, oh, right here. That's because I got that in the wrong spot. There we go. Now that's how it would look.
OH
Yep.
on the bottom or the left.
Yep. OH. That was not done on purpose. I mean, because we got about 6 minutes left. I was just doing that in a rather hurried manner. That's not how we want to go through it, but we just want to illustrate that you've been doing this all along. You just never applied it to 3, 4 carbon compounds. Okay?
What's the specify tomorrow? Just questions.
Yeah. It'll say draw the projection formula for probably glucose, mannose, ribose, those that we had asked you to do, and then it might say draw alpha D, whether it's threose or erythrose, which is, of course, a tetrose, and you'll know that it's an aldehyde when that double bond oxygen is on the first carbon.
Then will it tell you like the right line?
It would have to tell you the orientation of these as well.
Will you give us the football scene, or are you just gonna say?
No, I would just say, like for instance, draw this one, and that's all you would see. So, and I got that backwards. For only if it asks you to, because perhaps on the back page it might just say draw this compound. You can just draw the closed ring. Yeah, but we still want you to know this process as well.
And then when it says it, like where it says illustrate, like how it works or whatever, then you want to select box though.
That's correct. Just show a box that would be around oh, that hydrogen that goes down to this oxygen.
And there won't be any like one-form linkages and stuff. That won't be
Nope, there's no disaccharides on there. That's for another time. Okay. So we'll catch up to you next time.